Alright guys, so we're going to take a look at our unit 1 through 3 opener. This is a review for the first semester final exam. We're going to start with unit 1 here. We're going to look at a dimensional analysis problem. So this first problem deals with the concept of dimensional analysis. This is a fancy word that just means converting units. So if you want to convert from units of, say, inches to centimeters, or feet to miles, or anything that you pretty much anything that you want to convert units of, you can use dimensional analysis to do that. Okay, so the first problem, we'll just read through it. You're purchasing shoes online from a European shoe store that lists the shoe sizes in centimeters, but you only have a ruler that measures length in inches. Convert the length of your foot, we'll just say it's 9 inches, into centimeters. Okay, so first thing we got to do is look at what is the given information, because the given information is going to be given information is going to be what we start with. Okay, and what we end with is the thing we're trying to find, which is how long is that in centimeters. So we're starting with 9 inches, converting that into centimeters, and in order to get from this point, the starting point, to the ending point, we have to use dimensional analysis. We have to convert the given information into the final information. So in order to do that, we have things called conversion factors, and in this problem it's given, and usually on the final I'm going to give you these. The conversion factor. Okay. So that conversion factor right there, that is going to be our tool for getting from point A to point B. Okay. Here's the tricky part that most students have trouble with, and this is where I see the most common mistakes, is how do we set up that conversion factor? Because this is a ratio. We can set this up as a ratio in order to cancel out units. So because 1 inch is the same exact length as 2.54 centimeters, these two things are equal. We can also write that as a ratio, because that's just a 1-to-1 ratio, because these are the same length. So we can use that to convert units. Okay? Here's the thing. If we have inches to start with, that's what we're trying to get rid of. We're trying to get out of inches. Okay? That's what we started with. It's what we're trying to get rid of. So we're going to put inches on bottom, because if you divide the starting inches by the unit inches again, they're going to cancel out. Okay? And we're trying to get into centimeters, so then you put centimeters on top. Okay, so I kind of left a lot of space here, because all we have to do now is multiply the numbers now. So first we're kind of dealing with, like, what are the units, and how do we set up the conversion factor appropriately? Well, we did this so that we could get out of inches and into centimeters. Now we have to crunch this number. So it's going to be 9 times 2.5. We're dividing by 1, so all we have to do is multiply 9 by 2.54. And you should get 22.86 centimeters. Okay, because, and you can kind of double check your work. 9 inches, okay, at 1 inch is equal to 2.54 centimeters. So an inch is a centimeter is about 2.5 times bigger than an inch. So your final answer should definitely be bigger than your starting answer, just based on, using common sense and the conversion factor. Okay. So that's dimensional analysis. There are other types of problems involving the metric system too that you need to know for that. The second problem in Unit 1 that we're going to talk about is a density problem. Okay, so we're going to look at density. This question starts with, the mass of a soda you are drinking is 500 grams. If the density of your soda is 1.2 grams per mil, what is the volume of your soda? Well, there's a very important formula that we need to know for this problem that's going to make this a lot easier to solve. That is a relationship between density, mass, and volume, and that is that density is equal to the mass over the volume of a substance. Okay, so we want to go through and figure out, what do we know and what don't we know? Well, we know the mass. Okay, so we got that. The density of your soda is 1.2 grams. We know the density. And they're asking us to find the volume. So this is what we got to find. Okay. The easiest way to do this, okay, would be we need to find volume. So we're going to move the variables around first, because it's easier just to plug in than to have to move to plug in after you move the variables around, then to plug the numbers in and then manipulate the formula the other way around. So we'll try it this way. So we need to solve for volume, and this being on bottom of a ratio is not going to work, so we got to get it over to the other side by itself. Okay, so the easiest way to get rid of something that's in the denominator of a ratio is to multiply both sides by volume. So I'm going to start using letters now to signify these things. Okay, then we just divide by density on both sides, so we get volume equals mass over density. From here we just plug in, so we want to know what the volume is. We plug in the mass, it's 500 grams, and we divide that by the density of 1.2 grams per mil. Okay, plug that in your calculator, you get a final answer of 416.7 milliliters. Okay, double check that unit at the end, because you're starting in, if you're trying to find volume, you know that the unit then should be a volume unit. Okay, if you ended in grams, you know you did something wrong. Okay, so that's the answer for the second problem. All right, next question concerns types of matter. We also looked at, in Unit 2, we looked at matter and change, so physical and chemical change. Okay, so we're looking at a problem. This is kind of a common type of problem, is to look at a sample of matter and try and figure out whether that matter is made out of elements, compounds, or a mixture of elements, or mixture of compounds, or a mixture of elements and compounds together. A mixture is a physical combination of two different substances. Okay, so if you have a mixture, you're going to have different substances within the sample. A chemical combination of substances would give you either a compound or a molecule. So if you see things bonded or attached to one another, that is a chemical combination. So let's just go through and kind of label these things. So we're going to look at the first sample here. This has, we're going to look, if something's by itself, this is an individual atom, then it's an element. It's not bonded to anything else. It's as pure as, it's as simple as it could possibly be. This is one element. Okay, this is another type of, this is another atom for another type of element. Okay, so we have two different kinds of elements. So already we know we have a mixture of elements. But what is this thing here? Well, we have something that's chemically combined. We have a mixture of, these are elements, and then we have a compound here because this thing is chemically bonded to itself. So this is a mixture of elements and compounds. Okay, moving onward then, so that's the first one. The second one, we look in the circle in our sample and we see that, well, there are 3 atoms in here. They're all the same color and they're all by themselves, so they are the same type of atom, which by, and if you remember Dalton's theory, is that all atoms of the same element are alike. So they're exactly identical to each other. So this is just an element. Okay, moving on. So here we have we've combined atoms to form something, in a bigger, more complicated type of matter. So this is a compound, and you want to look at, we want to see, now we have 2 compounds in here, and we got to double check to make sure that they're the same. Otherwise we would have a mixture of compounds. But if you look here, we have, this guy has 2 of these black atoms and 2 of these white atoms, and this guy has the same exact structure and amount of atoms. So these are identical. So this is just a compound. It's not a mixture of different types of compounds, it's just the same, those are the same thing, so it's a compound. And then this last sample here, we have 2 atoms here that are the same, that's an element. 2 atoms here that are the same, that's a different element. So we've combined physically 2 elements. They're not bonded, they're just a physical combination or a mixture of just elements. All right. Okay. So that's Unit 2. There's more to Unit 2 than just that, but that's a good place to start in your studying. All right, backside here. Unit 3, Atomic Theory. So we're looking at the structure of the atom. Okay. Typical type of problem would be I'm going to give you a table like this, and based on your knowledge of atomic structure, where what the nucleus looks like and how the electrons are arranged, you should be able to fill this chart in and give me the symbol. So we're going to go through and I'll kind of define some of these terms as we go through and show you how to solve one of these problems. So the first problem we're going to look at is calcium. Okay, and we need to know some information about calcium. Okay, one thing we know about an element is that it always has different atoms, ions, isotopes of the same element always have the exact same number of protons. Where do we find that number of protons? Well, we're going to look at our periodic table. Okay, so from the periodic table, we should know that calcium is always going to have the same number of protons. It's going to have 20 protons. So that's the first thing you can write down for sure is, well, calcium definitely has 20 protons. Neutrons, we'll use that in a second here. Those are also in the nucleus, and then the number of electrons will help us determine whether or not this is an ion. Okay, so the atomic number, which is also, that's the same thing that we just looked at on the periodic table, that's the number of protons. So these two columns are always going to be identical. Okay, the mass number is the number of protons plus neutrons that are in the nucleus, because protons and neutrons are the only thing that contribute mass in the nucleus. So we add the protons and neutrons, we get 41. Okay, the element symbol. So for calcium, we know the symbol from the periodic table, but we have to add a couple other things. We have to put the mass number goes on top, and then the number of protons, or the atomic number, goes on bottom. Okay, so we know everything about the nucleus on this side, and then we have to say whether or not this thing has a charge, because we need to know whether or not it's an ion. So if you look at the number of electrons versus the number of protons, that's how you determine if something has a charge. Remember, electrons are negative and protons are positive. So if you have 20 positive charges and only 18 negative ones, you have 2 more positives than you have negatives. Okay? So that gives you an overall 2+ charge on calcium. Calcium is an ion and it has a 2+ charge. All right, going to the second problem, kind of the reverse here. We're given the number of protons, so we got to look at the periodic table, figure out what the element with atomic number 6 is. That's carbon. Okay, so the element is carbon. It's got a number of protons of 6. Right away, we know that's the atomic number. How do we figure out the number of neutrons? Well, we know the mass number is 13. That's the same thing as the number of protons and neutrons. So 13 minus 6 gives you 7. Write the element symbol.